Let's break down how OpenClaw works under the hood without all the hype. It's pure and elegant engineering. And at the heart of everything is the gateway, which basically is a traffic router. It receives different types of inputs. Its only job is to receive these inputs, tag them, and shove it into the queue for the agent. In this architecture, gateway is the dumbest part, but it's always on. All the action happens inside the agents. You probably have heard that it's proactive and it feels alive. It all comes down to the inputs. There are 5 different types of inputs which makes this system alive. Each one of them triggers an event at the gateway, and in the process, the agent responds. But here's the most interesting part. Not all of these inputs are human initiated. There are messages like Slack, WhatsApp, or Telegram messages. Then there are other types of messages which are triggered by the system itself. So we have heartbeat, which initiates every 30 minutes. Then we have cron jobs, which initiates as a user defined time. And these can be irregular as well. Then we have, which are external API endpoints that initiate certain actions. And then we have internal hooks, which are internal state changes that is going to trigger events at the gateway, which in response initiates or wakes up the agent. And when you combine all of these, you get an agent that operates 24/7 without you ever touching the keyboard. And it feels, so you probably saw this phone call to a developer that went viral. So let's break it down why exactly that happened. Now, here's what happened. So there was a pre-configured cron job that got fired at 3 a.m. This is basically a system clock trigger. The gateway saw that and pushed a check urgent task to the queue. Now, as a response to this, the agent woke up because that's exactly what it's supposed to do. It read through the instruction.md. There was an instruction which explicitly said, if you find a server crash, call me. As a response to this, it checked the email server logs. It found a crash. It already had access to the Twello API. So as instructed, and simply made the call. So as you can see, it wasn't a decision made out of fear. It was a logical flow. There is a trigger, instruction, tool execution. It's just code. But this is a very elegantly designed system. The agent is responding to triggers, whether they are human initiated or system initiated. Now, here's where things gets very interesting. You can have multiple inputs try to initiate or trigger the gateway simultaneously. So the question becomes that what happens when you spam the agent or when webhooks hit the exact same time as the heartbeat? The gateway is going to put everything in a queue and the agent is going to pick one task at a time. So depending on if you have multiple different agents set up, they can take tasks from the queue simultaneously. There are situations in which a single agent is not going to be enough. You want multi-agent systems. And OpenClaw supports the multi-agent setup out of the box. But here's where it gets more interesting. They don't use a telepathic path, but they use the gateway for internal communication. If an agent initiates a trigger, it is going to be put into the queue just like any other trigger. Let's say we have 2 different agents. One is the research agent and the second one is the writing agent. Now let's say if the research agent finishes a task, it sends a message back to the gateway saying, tell the writer agent to draft this. Now to the gateway, that internal message looks exactly like a user message. It's going to route it to the writer agent's queue and it's going to wait for its response. Now this allows you to change complex behaviors while keeping every agent isolated in its own workspace. So this whole setup is a very elegant example of event-driven development. So essentially it's a forever running loop that tracks events, put them in the queues, agent take actions, update its states, but by keeping a history of all the actions that have been taken so far. How exactly does it remember things? It's actually surprisingly low tech. So OpenClaw doesn't rely on complex, expensive vector databases for everything, just simply uses markdown files. So every time an agent is woken up by an event triggered at the gateway, it simply reads this markdown file that contains the history or memory of the system. So essentially, It reads its own diary before it says a word. And this is what makes the state persistent, human readable, and incredibly fast to load. Now, the last piece of the puzzle is the tools that the system has access to. Some are built-in tools. It can read files on your local system. It can use bash command, use your terminal. And then there are some external tools like API endpoints that you connect to it through skills. And everything that it learns about new skills or how to use a new API, it's simply read into a markdown file. So in theory, it's a very simple system. And this is what it makes it very impressive as well. And to be honest, you can put together something like this with an agentic system like Cloud Code, Agent SDK, or even the Agent SDK from OpenClaw. Now, most of them are not persistent. So you will have to come up with this gateway implementation that is going to not only route your inputs or system events into this queue, but also trigger or wakes up the event or the agent. Now, remember I said everything goes to the gateway, even if it's communication between two different agents. Everything looks like it's coming as a trigger. And since we are storing everything in the form of markdown files, well, this is where some of the prompt injection related issues comes into play. The event trigger puts everything in the queue, and you can have some prompt injections that are going to pass on through the context of your agent or LLM. And there is a big issue related to skills that OpenClaw has access to and it uses. Now, the good news is that they are actively working on it. There were some malwares available on ClawHub, but the developers are actively addressing those issues now. It's worth checking out in a sandbox environment because this gives us a glimpse of what the future of personalized AI assistants could look like. So this was all the magic that happens inside OpenClaw at a higher level. It's just event-driven development with triggers created both by the user as well as the system and external hooks. And the agents are responding to those. It's simply elegant engineering, which makes it very special. Anyways, I hope you found this video useful. Thanks for watching. And as always, see you in the next one.